Greetings and welcome to Chapter 1, Sampling and Data. We're going to focus on 1.3 today, frequency, frequency tables, and levels of measurement.
First things first, go through the terminology for this section. Click on each of the words to become familiar with its definition and meaning. Data has 4 levels of measurement. From the lowest level to the highest level, it's nominal, ordinal, interval, and ratio. So we've already kind of talked about in a previous lesson nominal and ordinal. Nominal, to refresh, is named values. In other words, it could be something like a color, a name, a reason. It's not ordered. There's no particular ranking. It's that blue eyes aren't better than brown eyes type of situation. For example, why people travel. Perhaps it's for leisure, perhaps it's for work-related or visiting friends and family. There's no better reason to travel than another, so it is nominal. Now, one level above that is ordinal. Ordinal is extremely similar to nominal. They are named values, variables, but they are also ranked. They are ordered, so one is better than the other. First place, second place, third place. First place is a higher ranking than fourth place. It's very similar to a hot chili pepper scale. So you have a pepper that has a light hotness, and then you have something that's screaming hot. The next level above that, the third level, is the interval level. And these kind of grow on themselves. So it's named, it's ordered, but it's also a proportion between the values themselves. So think about a thermometer. And think about the 2 scales that are usually on a thermometer, Celsius and Fahrenheit. Now for Fahrenheit, you can do some math on it, like 100 degrees minus 60 degrees is 40 degrees. So the proportions in between those degrees are meaningful. Same way with Celsius, you can take something like 30 degrees Celsius minus 10 degrees Celsius is 20 degrees Celsius. The differences, the proportions between the individual values remain constant.
In both of these scales, Fahrenheit and Celsius, the 0 is fairly meaningless. It's just a transition from positive temperatures to negative temperatures. The 0 doesn't mean absence of heat or no heat. It's just the transition between positive and negative numbers. And therefore, we have one more level of measurement, and that's called ratio. So when it is named, it is ordered, it is proportionate intervals between the variables, and it can accommodate a meaningful 0. Something like the numbers of brothers you have. If you have 0 brothers, that means you have no brothers. That's meaningful. The number of bicycles you own. The weight of something can be 0. So those are meaningful zeros. We're going to change our focus to talk about frequency tables, and therefore we need to talk about the math that goes along with building a frequency table. Frequency just means you're going to add up, or the summation of the number of times that something happens. So let's say we have a room full of people. Some people have blonde hair, some people have red hair, some people have brown hair, and some people have blue hair. The frequency of blonde people would just be how many people have blonde hair. That would be the frequency. The total frequency is just the summation of all the frequencies, meaning you just add up all the frequencies. Let's say for that example of blondes, brunettes, redheads, and blue-hairs, it's just how many total people are in the room. That's the summation of all the frequencies. Relative frequency is going to be the frequency of that particular thing happening divided by the total frequency. So the relative frequency of the blondes would be the number of blonde people divided by the total people. Now, the cool thing about relative frequency is it will also tell you what the percent of that object is compared to the whole. So all we have to do is take the relative frequency and multiply it by 100, and that gives us the percent. The next thing we're going to talk about is cumulative. Another way of looking at cumulative means it's just a running total. You add it up as you go. It's very similar to playing a card game where you have lots of rounds of the card game and you add up your points after every hand that you play. So for example, place a game and you get 25 points at the end of that round, your score is 25 points. You play another round, you get 12 points. Now your total score is 37 points because that's your running total. You add the previous total to your new score, and that is your current running total. Depending on what the object is that we will add up, let's say we want the cumulative frequency. So we would do a running total of the frequency. We will add it up as we go. Each time we get a new number, we add it to the old running total. Cumulative relative frequency is the same idea, but we do it on the relative frequency column of the table instead of the frequency. So we have cumulative frequency, that means the running total of the frequency, and we have cumulative relative frequency, just means the running total of the relative frequency list.
Frequency tables allow us to organize our information in such a way and gather information out of the raw data very quickly. So let's take a scenario. 20 students are asked how many hours they work per week. Their responses in hours are as follows, and the data is there. Now, just seeing the data, it doesn't give us a lot of information. In fact, it's very hard to read. But we do have some reoccurring values. It looks like our lowest value is a 2, our highest value is a 7. And there are 3s, there are 4s, there are 5s, there are 6s. So to clean up our data and make it a little bit easier to read, let's create a table. And I've listed the column headers that we're going to be working with: hours worked, frequency, relative frequency, cumulative relative frequency. The hours worked are just going to be those categories that are in the raw data itself. We have some people that worked 2 hours, some people that worked 3 hours, some worked 4, some worked 5, some worked 6, some worked 7. So those are going to be our categories of hours worked. Yes, I know they're numbers, but they're still categories. Now, what we want to do is figure out the frequency of each of those categories. How many students worked 2 hours? And when I'm looking at the data, it looks like 1, 2, 3 students work 2 hours a day. So their frequency for 2 hours worked is a 3. And we're going to continue with this for each of the categories of the hours. So 3. I'm looking at the raw data, and it looks like there's 1, 2, 3, 4, 5. So 3 happens 5 times. 3's frequency is 5. And we'll do this for the rest of the values. I'm not going to bore you walking through each one, but you're just going back up to the raw data, seeing how many 4s there are. Going back to the data, how many 5s are there? How many 6s are there? And how many 7s? Once you've figured out all the frequencies, you fill in the table. Relative frequency is how often means frequency, compared to the total amount of frequency. Now remember, we asked 20 students. So when you add up the column of frequency, you would get 20. And just to double check, 3 plus 5 is 8.
8 plus 3 is 11. 11 plus 6 is 17.
17 plus 2 is 19, and 19 plus 1 is 20. So the total amount of our frequency is 20. Relative frequency means the frequency divided by the total frequency. In other words, 3 divided by 20, or 0.15 for the 2-hour work. We'll do this for each of the categories of hours worked: the 3, the 4, the 5, the 6, the 7. For the 3, it happened frequency of 5. So 5 divided by 20 is 0.25. And we'll fill out the rest of the table this way. Cumulative frequency just means a running total of your relative frequency. Running totals means, okay, you take the first value, which is 0.15. So for the 2-hour work, the cumulative relative frequency is 0.15. Now, to get the cumulative relative frequency for the 3 hours worked, you add the 2-hour work relative frequency plus the 3 hours worked relative frequency. 0.15 plus 0.25 is 0.40. And you do this for each of the values. So the next value would be, the cumulative frequency would be this 0.40 you had before, plus the new value of the 0.15, in other words, 0.55. And you would continue to fill in your full table. You've reached the end of this lesson.